So this is my work office lab. Got a whole bunch of stuff.
Bar in a minute if you want to see it with a bar.
Yeah, we're okay for sign at the moment.
It's got that noise.
only expecting it to potentially trip as they start raising. So they only raised it 10% last time.
Did it trip after 10%?
I don't know. So here's where we'll find out.
A bit quick, man.
Not bad.
A lot faster than the other one.
So you haven't seen this lift before?
Yeah, we lifted this morning.
Okay.
Last,
on the other one?
Yeah.
On E2?
Yeah.
Not our one?
No, it lifted on the other one, and it was about 60 seconds going up and 72 seconds lowering back down.
So this is faster?
Yeah.
And I haven't heard anything change over there? Okay. So if they work, I've saved them. So if they work, why change it?
If it works, we'll keep it at this.
Alright, so now potentially we could trip. Quite a fair bit slower, but you'd expect it to be slower, right?
Clamp down once it gets to the bottom.
And then the chocks.
Down so the wedges can then go in and lock the bridge into place.
I mean, that's great that we got to see a full lift up and down.
Did he have to do that?
Second breaking off.
Oh, okay, that's fine.
So double circuit. So which one, that one?
Yeah, go on. That's kind of stalled now.
When I GSC, is it?
I don't know.
But we can't have it on the filter. Okay.
I would have wanted to go with time with filters.
Yeah.
were you telling it that the accumulator was charged?
So what? Oh, that's pretty fucking cool. Is that?
Yeah. I know Westlands is on its own supply. Well, the ring doorbell worked about 10 minutes ago. So. Right.
I'm just going to go get a latte for that valve because obviously there's
I thought you said you're gonna get a latte.
got main motor running flat as well.
22 degrees.
Has it always been like that?
Yeah, but I've been here 9 years. I've been driving this 5 years, and it's been like it. And we get some hard stuff. It's been in the furnace and out the furnace a couple of times. That the bars tend to harden up, and smaller diameter bars, when you've got corner forging on it, and it just jumps off. The bar will spin, or the jaws will spin, and then the crosshead will bang down on the bar itself. Do you want to jump in, Liam? Yeah.
It's not really for you, it's not really for my own interest. But if we get a system that catches it and sees what they are changing to, then
Yeah.
it should be.
25 mil.
You nudge it again? So you know when it goes to 820. There you go, yeah. Sorry, we can do that.
So that stays on 888 until.
Is that the vertical position? Press position? Height?
Yeah.
Yeah, I guess so, yeah. Yeah. There you go.
So now it's dropped to
400.
So that'll be from the top tool to the top of the switch
Bottom.
tool.
Okay. But why did it take so long to update that?
So we go from one side to the other. So that should go in there.
So is that based on a proximity switch then?
It can't be. I'm on site right now, full PPE gear. We are commissioning. Can I turn it around so I can't? So this is what the bridge currently looks like. The road comes up there. From there, that's the control tower. The control room will be all the way upstairs. I was in that pump room over there, and then the bridge goes along there. And then this bit is where the basket is going to sit, as the bridge will roll backwards across this lake. Hi guys, how you doing? Hope you're all well. So it's been a month now since I showed you guys the bridge that I'm commissioning down in Suffolk. And yeah, it's going very well. So let me give you a quick tour around. So I haven't been here that much. I've done about 3-4 weeks here. So last time in my video, I went out that elevator there, and then I showed you the bridge. But well, I went out that entrance over there. I'll show you, but there's now an elevator there. Very, very windy. So that's the elevator. Current entrance. Walk in. There's going to be, I think that's the shower, I think. And then this is a comms room. Then there's another comms room. I don't get involved in any of the domestic wiring, that sort of stuff. Then this is where my remit begins, which this is the generator room. So this massive storage container thing is a generator, massive diesel generator, and then these panels are the panels that my company designed and then I tested them. So you got big air circuit breakers here. So these are rated at 1,600 amps, big boys. Let's see if we can open the generator. There we go. So this is the HMI for the generator, and then a bit of a power control panel, and that's the massive generator, big diesel generator. So I'm actually going to communicate to this via Modbus. I'll climb inside quickly and show you the control board. So if you don't know, Modbus is somewhat old technology, but it's really good because you can just talk to everything. So this is the board of the generator, and then that board over there, I'll be talking to it from my PLC via Modbus, which is pretty cool. 600 volts AC. It's pretty amazing, really, the circuit board. Obviously this is no diesel fuel in here and it's turned off, so no chance of it starting. Yeah, big fat diesel generator. Alright, so I'll go through like the power diagram design another time, but basically what you want is, we've got 2 transformers outside and they basically drive all the hydraulics that lift the bridge. Let me close that door. So yeah, the transformers drive motors which drive pumps, hydraulic pumps that lift the bridge. And this is basically for if any of the transformers fail, then I need to be able to kick this generator in. So this is the switchboard room. So over there, outside that door, there's 2 transformers. They then bring in 1,600 amps each. One into this panel via the floor, into that panel, and then one into this panel here. So if I went in there now, there's live, I'll show you actually, but as long as I don't actually touch anything, these are some big live bus bars. Just look at the size of that cable. Ridiculous. Yeah, so that's live now. So those come into these ACBs. These air circuit breakers, I can switch them remotely via the PLC. So what you've got is, you've got 2 switchboards, switchboard A, switchboard B. One of them powers this panel, which is like the PLC panel. So this is where you've got all of your network switches, blah blah blah. And then here's the PLC rack, 1500 PLC with ET200 SP remote I/O. So that controls this tiny thing, lifts the whole entire bridge. So if I come out of here, so that's the switchboard room. So if any of those transformers fail, then I need to detect the failure, knock off this switchboard, bring in the generator, and then send the generator power over to the hydraulics. So this is the hydraulics. So you've got 8 massive main motors, 132 kilowatt. These are controlled by these starter panels. So you've got one HMI here. There is actually like a control room upstairs where the operator will sit. So this down here is just really just for maintenance. But so that's the layout that I just showed you, whereby you got the generator, you got the generator panel, the PLC control panel, the 2 switchboard panels, and then now we're at these Power Pack A and Power Pack B panels, and these feed these 2 massive hydraulic HPUs, hydraulic power packs, power units. So alright, so I got motors, and then let me configure which ones I want to start. So B, and then let's just do one main motor. There we go. Overview. Start one. Very, very, very loud. Yeah? Yeah, pilot pump's still running. There you go. That's just with one main motor, so with all 8 is extremely loud. And that's with them offload as well. When they loaded, as in the pumps are actually delivering out to the bridge to lift it, it's extremely loud. This is before running anything. So I'm working on these 2 test rigs, and what we've done so far, or one upgrade we've just done, is I've added in a key switch here so that you can disable the rig and work on it. So I'll keep that rig enabled. If we go over to this rig and then disable this rig. So this rig's currently enabled. Disable it, take the key out, and then now what you can do is, so this rig has e-stops on it, and downstairs is a HPU which I can take you to. So this e-stop now will be ignored. You hit that e-stop, nothing happens, and what it means for the electrical guys is that they can come inside this panel, turn off the power and start working in here whilst there's a test going on that rig over there. So I'll take you down to the HPU now, but yeah, so now if I now with the so if I put the key back in actually, and then so now that's now enabled, then if I turn the power off now or e-stop it, then it will kill the HP downstairs. So you can probably hear the HP. So if I hit the e-stop, kills the HP downstairs. So this is a key switch that enables and disables the e-stop or the rig upgrade. So that's one of the upgrades that I came to do today, and that works the same on both. So you probably can't hear me because that rig's running. This one's not, but this rig's running. This one's RH for you. So you got the electrical panel. Oh, that's actually the one that's running, but this is ours. We've got circulation pump and then 2 main motors, or 2 main pumps. So yeah, that's the rig. Yeah, I'm right, Steve. Yeah. to show my dedication, it is currently 1:30 in the morning and I'm in the office. 1:30, dark outside, in the morning. And I'm fasting tomorrow. But yeah, here I am.
Because at the moment I do check encoders, so if it bounced, you used to do about.
Ivor, there seems to be a problem. So I'm on SWBC card, yeah, IO screens, and if I hit like the bridge lower button, the generator fuel level okay input's coming on. So I guess we've got an addressing problem. If I hit the bridge raise, then the generator running signal comes on. If I turn controls on or off, then I get the main generator selected. So I'm guessing that's probably why that card also isn't currently working. So yeah, bit of an issue here. So this is inside now. So this is the main LV room. In this room now, so this room gets fed into the floor here, and then another one into the floor here, which is fed from each one of those transformers that I showed you outside. Those two out there. So cable literally comes down there, through the floor, through the floor, and then you can see it in there, yeah? So what's happening to me at the moment is those two transformers I'm tripping the circuit breakers on them, and I'm getting about 50 amps when I'm lifting a bridge on full angle at full speed. So I've got all of my pumps on full speed, going as fast as they can, and I'm tripping the transformer circuit breaker out there. Then I've got to call the engineer that owns the transformers to come out. That takes him 2 hours to come over here and reset the breaker. What should be happening is the transformers get fed through the floor into here. This circuit breaker here is rated at 1600 amps. This should be blowing, so I've got it. So if you don't know, I've got LSI settings here on the circuit breaker. So to show you what they are, you've got IR, which is overload. So this is the percentage that you want. So if it's 1600 amp breaker, then your IR settings there are 0.85, so it's 85% of 1600 amps, probably about 1300, 1400. And then you've got so the duration at which it sustains that overload. So here it's 2 seconds. 2 seconds, and then this should blow, which it's not at the moment. Then you've got short time duration, and you've got instantaneous. So these LSI settings, they're currently, for whatever reason, not correct because it's not blowing when it should be. So this is closed at the moment. What should happen is that when this sees 1500 amps, this should open. So this is the main circuit breaker, which isn't blowing at the moment. This then feeds, so this feeds into this circuit breaker, which feeds which is fed from the generator. Sorry, actually, opposite way. This doesn't feed this. This is fed from the generator, so ignore this ACB. This transformer here goes to this circuit breaker, which feeds into the main building panel, which powers all like the PLC and everything. Ignore this. This is on my test cable, which it basically needs to be wired properly, but I just did it yesterday for test. So this feeds the building. Then I've got the hydraulics next door, which I'll show you. The hydraulics are fed from this circuit breaker here, which is a 1250 amp 4-pole circuit breaker, ACB. So this is rated, this ACB is rated lower than that ACB. That ACB should be blowing at 1500 amps. It's not blowing. This one's 1250 rated, and I've got it set at 0.95. If you can see that. Yeah, 0.95. So that's even lower. That's like 1100 amps, and this one isn't blowing. This then feeds into the hydraulics. So all of this is duplicated, right? You've got one transformer feeds this feeds this ACB feeds the hydraulics next door, and then you got a different transformer feeding this ACB. This ACB then feeds this 1200 amp one. And again, this isn't blowing. So I need to adjust the settings on the main incoming transformers. Sorry, the main incoming ACBs, these. I also need to adjust the settings on these, on this ACB, because this isn't blowing it should be blowing at 1100 amps, and it's not. Then if I take it next door to the hydraulics, so this is these are the HPUs, these are the hydraulics motors, pumps that lift the bridge. So from inside there in the LV room into here, these get fed, feeds another 1250 amp circuit breaker. And again, this one should be blowing, that's down at 0.75, so this one should be blowing at like 900 amps, and it's not. So I'm gonna get a screwdriver and adjust these LSI settings. First, let me show you what happened yesterday. So if I need to find where it was yesterday. So let's do transformer current, select time. We're gonna do, let me change the date. Why can't I change the date? Have I reset it? So the last thing I'll do is, and I've just done it, is on this main incoming now. So you've got the main incoming from the transformer over there, yeah? So the main incoming one, this one I have comms on, so this is actually the one that I'd like, because basically this is on Profinet, so I can read everything that this one's doing all the time. It's got loads and loads of features, these ones. So I've set this now, so the overload setting on this is set at 960 amps for 1 second, and then the short time duration is set at, let's go lower, 960 amps as well, and instantaneous is set at 2400. So this one should blow as well now. Not as well, but one or the other. So I'm hoping that I can crank that one in there on the HPU unit back up and let this one blow. The only problem with this one blowing is that when this job's finished, this whole PLC will be connected to a UPS system, so an uninterrupted power supply, i.e. a battery. So even if you lose both the transformers out there, you'll still have the PLC. At the moment, the battery's not in, so therefore, once these get knocked off, once one of them gets knocked off, whichever one's feeding this panel at the moment, which is currently this panel. So once this panel gets knocked off, the PLC will turn off. So it's not great for me because I'll have to come down here and reset it. But yeah, maybe what I do is I just lift and use one unit. Yeah, we'll see. Anyways, thanks for watching. Well, stop it. Stop them. Stop all of them. Hello. How cool is this? Like, I'm the only person on this bridge. Pretty sick, isn't it? Soon, one day soon, this is going to be packed with humans driving up and down. It's a pretty cool project, man. Pretty cool.